think that if I actually, okay, so comparing the size of the product to the size of the factors. That sounds like what we were having to do with that one homework with number 1, A, B, C. Where if we had the problem, and it looked like one third times 1 equals 1/3 times 3/3 equals blank over 9. This was on your last homework that you did. This was your homework that you had. And what should be in that blank? A 3. This relates to our lesson today. So everything ties in to everything else. So then you had D, and it said compare the first factor to the value of the product. And you read that and you go, what are they talking about? And you say that the first factor would be this. And the product is this. Your product is your answer you get when you multiply. Adley, are you kidding me right now? So, comparing your product to your first factor. When you do that, you can say that you should be able to say that they are the same. They are equivalent. They are equal. Now, they're obviously not identical, but they are equal. They are equivalent because you multiplied by 1. You multiplied by a number that is equal to 1. Please sit down. Sit down. You multiplied by a number that was equal to 1. This is very relevant to what we are doing today. This is the foundation of what we are doing today. Okay? This is like if I had a porch, these are the supports that were holding up the roof. Okay? This is the whole, can you agree with what I'm saying? Sophia's like, yeah, okay, I think you made your point. Please stop. Right? She's like, okay, you made your point. Shut up. But I'm not lying. So any number, if I said I multiplied it by 1, I would get the same thing. Yeah? So, I made my point. I killed it. I beat the horse. It's dead. Be quiet, Strick. The horse is dead. I beat it to death. So 3/3, 4/4, 5/5, 10/10. You know, some people think that just because the numbers get really big, it makes a difference. A million millions. What can you say about these? They are all equal to 1. So, what could you say if I had 4/5? How would that compare to 1? The whole number 1. How would 4/5 compare to 5/5, which is equal to 1? How would 4/5 compare to 1? How does that compare? That doesn't answer my question. How does that compare? Compare greater than, less than, equal to. How does it compare?
Oh.
Greater than, less than, equal to?
Less than.
Less than. How do you know?
Because 4 is less than 5.
Because 4 is less than 5. Okay. Yes? So, what if I had 6/5? How does that compare to 1 or 5/5? Yes? Because
Because 6 is 1 and 1/5, and 5/5 is just 1.
Because 6/5 is greater than 1, it's improper. 6 is bigger than 5. All of these things. It's 1 and 1/5. It's bigger. It's improper. All of these. Right here. Bigger. All of these, you are comparing it. Really, you can compare it to its denominator. If it's equal to its denominator, this is smaller than its denominator, because if it's equal to its denominator, it's 1. If it's smaller than its denominator, it's less than 1. If it's bigger than its denominator, it's more than 1, because then it's improper. Yes? No? Maybe?
Yeah.
Are you sure? Because I got some people who are just kind of off looking at the wall. If you're looking at the wall's not teaching you anything. The wall is boring and white. I'm way cooler than a wall, I think. I don't know. I mean, the wall's got neat posters on it, but I would like to think I'm way cooler than a wall. I don't know. Sometimes I'm not cooler than a wall, but it would have to have a really neat poster on it. Wall right now is not teaching you anything but how to multiply, and you already know that. How to do a mixed number to a fraction, you should already know that. And how to do an equivalent fraction, you should already know that. So I'm teaching you something you don't already know, so I am way cooler than a wall. So, what are we going to do with this information? So all eyeballs should be up here unless you are writing something down. Thank you for writing something down. I'm talking about the people who are just kind of staring off into space, because you are going to have homework tonight and you are going to be having a test very, very soon. So staring off into space, not a good idea. Yes, it's easy. I'm telling you, it's a lot of mental math, because you're not solving anything today. It's not really any work. It's just, I know this because. Really, it's a whole lot of I know this because. All right. And I don't need this. So if I had, based on what we know about our fractions, we're not solving anything. I don't want you writing it down and trying to solve it. We're doing this all here. And I don't want you doing smoosh math and going, I know this because the answer is this. This. 4/4 times 12. If we are going to compare this to 12. I'm kind of skipping ahead because we need to do this. If I'm going to compare this to our first factor, because I'm taking a fraction of a number, would this be greater than or less than 12? If I take 4/4 of 12, would this be greater than, less than, or equal to 12? Adley,
It will be less than 12.
why do you think so?
Because 12 times 4 equals 48, and if you do both, then
Why are you working it? Stop working it. You're working it right now. What do we know about 4/4?
It's equal.
It should be equal. But see, you started working it. Oh, because 4/4 is equal to 1, and 1 times 12 is 12. So because 4/4 is 1, it's 12. So you should be able to go, oh, that's gonna stay 12. My product of this, without even doing any work, I should look at that and go, oh, it's gonna be equal, without even having to work it. Because you know that your fraction is 1. 3/4 times 12. If I'm comparing the product of 3/4 times 12, my product of this, is it going to be bigger than, smaller than, or equal to 12? Based on what you know about this.
It's going to be smaller because 3/4 is less than 4/4.
It's going to get smaller because 3/4 is smaller than 4/4. So your answer is going to go down. It's going to get smaller because this is smaller than 1. Yes, sir? It's actually 9. This is actually 9.
Yeah, that's what I was saying. So can you if you do that and you solve and you say it's smaller than, can you just check?
You can check it. I'm not telling you don't ever work it, but if you want to I just want to check it just to be sure, that's fine. Because I know that some people will just be like, work, done, and that everything would be wrong. So, and I do believe that sometimes I have said, I want to see your work. But really, I've actually said, write your reason off to the side. And I think on the homework it says, write your reason off to the side. Because it's really, because 4/4 is equal to 1. Because 3/4 is less than 1. So, what would if we were comparing this to 12? 5/4 times 12, our product, would it be greater than, less than, or equal to 12? Haley? Exactly. Because 5/4 is greater than 1.
Or not.
So this, oh wait, I forgot to write that. So this is greater because 5/4 is greater than 1. And so you don't have to do the work there. You can just kind of go, oh, this is that because that is that. Yeah.
We do check it. 12.
How's that?
Ask me that and I already answered that. Yeah, I think I did. I think I already answered that one. Honey, most of the time I tell y'all not to do things in your head.
Yeah.
But there are also times when I say, do it here to see if your answer makes sense. When you kind of go, I should have this. Then work it. Because if I'm asking, you have 2 feet, how many yards is that? And then you tell me you have 20 yards. Is that a normal answer? No. you have 2 feet, you shouldn't even have 1 yard. So you mess up somewhere. So you should do a little bit of mental math, seeing if your answer is rational. So that's what this is. Kind of going, my answer should be this because. And then you can work it, just to check. I'm not saying you can't. I'm just saying this is, I know this because. Does that make sense?
Yes.
So, with a fraction, 4/4 times 1/3, and you're comparing your product of this to the 1/3. Now, I'm not comparing my 4/4, obviously, because that's this. I'm comparing, woo, that's what happens when you accidentally touch the board. Well, I don't want to erase the whole thing. Let me get rid of that. I'm comparing the entire product to my first factor. So, what I get, greater than, less than, or equal to 1/3. Jaden, what would I get? Imani. Why? It would be equal because 4/4 is equal to 1. Now, if you wanted to check it,
I don't understand. Oh, that's how you.
then sit up.
I'm looking. I'll just
3/4 times 1/3, comparing the product of this by the original 1/3. What do you think, Emily? Why? Yes. So it would, this product here would be smaller than the original 1/3 because 3/4 is smaller than 4/4. So it would make your answer go down when I multiply it. So because 3/4 is smaller than 4/4. So if you wanted to check that, 3/4 times 1/3, you would get 3/12, which would get you 1/4. And if you don't know which one's bigger, 1/3 or 1/4, you would need to give them a common denominator. If you really didn't know that 1/3 was bigger than 1/4. But if you think about a pizza, and you cut the pizza, 1/3's bigger. It's only got 3 pieces. Which one has the bigger pieces? The bigger the number, the smaller the pieces. That really only, but a lot of times it only, if you have a unit fraction, because, not always, but it's easier. Because I mean, if I only had to share a pizza with 3 people, I'd have a much bigger piece. Of course, I wouldn't finish it. I don't ever finish my food. And then 5/4 times 1/3, comparing it to 1/3. Oh, someone yelling out, not listening. April, what do you think would happen if I took 1/3 and I multiplied it by 5/4? Would my product here be bigger or smaller than the original 1/3? Why? Because we're looking at the 5/4. Because 5/4, that's the thing that we're multiplying. That's the thing that we're using to multiply. Because 5/4 is bigger than 1. 1 is what makes the 1/3 stay the same. And if 1 makes it stay the same, this is bigger than 1. So it's going to make 1/3 get bigger, because that's bigger than 1. So if you wanted to check it, 5/4 times 1/3, that gets to be 5/12. Of course, you may not know, again. So if you wanted to compare 5/12 and 1/3, well then you would have to get a common denominator. Because you don't know the difference between 1/3 and 5/12 and which one's bigger. So 1/3 with a common denominator would be 4/12. Which one's bigger? 5/12. It's not bigger by much, but it's still bigger. It's only bigger by 1, but it's still bigger. It really is.
This is like awkward.
This is what we didn't get to yesterday because I had that meeting. Yeah.
It's kind of taking something from a younger grade, but this was faster.
Yeah.
You did this last day? No, like
Same thing, but with decimals.
Well,
But it's really the same concept though. So what if I have 1/2 times 3/5, and I'm comparing it to 1/2. So what number would be, now I'm mixing them up this time. So this is my first factor. The number that would be a 1 that could turn into a 1, the number that's the scaling factor, as they call it, the number that's causing my fraction to change, is this one.
like
So-
the 5 or the 3/5?
Well, the fraction, the 3/5, is what they call the scaling factor. That's the thing that's either making it stay the same, get bigger, or get smaller. Okay? So, compare that numerator to the denominator. All right, Adley.
It is smaller because 5/5 is equal to it, so 5/5 is not as 3/5 is not as big as 5/5.
Exactly. So you still just compare your numerator to your denominator, and this is smaller. So it's still less than 1. So this, it would get smaller because it's less than 1. I jumbled up the order. I think y'all were thinking it was going to be equal, less than, greater. Equal, less than, greater. And I jumbled them up this time. And it's not even in the same order. Because before it was scaling, first factor. And this time it's first factor scaling.
That's what got me.
Yeah, they're in a different order. Yes.
Will we ever do something like 10/5 times 1/2? And then you get like 2, you get like 1? What?
Like
you would have
bigger number.
Yeah, like
You're making it harder than it needs to be.
I'm asking if we would ever.
I don't know. You're making it harder than it needs to be. So, because 3/5 is less than 5/5. So what if I have 1/2 times 9/5? So really all you have to look at is what number is on the back. This would be considered my first factor. So my scaling factor is the number that's not on the back. So this is my scaling factor, the number that would be the 1. So scaling factor is the one that I need to be comparing to 1. Yes, ma'am?
It'd be greater than because 5/5 is a more than factor.
Yes. So greater than because 9/5 is greater than 5/5. What? I heard a honk.
Oh, that was me. I thought it was less than. Close enough. How is it less
Okay. So is
I
it?
didn't recognize the 9 and the 5.
Do you recognize it now? Okay. And then, obviously, this one is the easy one to point out. I mean, I think that one's probably the easiest one to recognize. So, what would this one be? Equal.
Because 5/5 is equal to 1.
Right. So, because 5/5 is equal to 1, and any number times 1 is that same number. You need to find a way Okay, so with 23, it's the same concept, but instead of using fractions, it's using decimals.
Oh,
It's the same thing.
okay.
Well,
You can like convert to the same factor.
Well, at the beginning, it starts off with fractions, and then it goes into decimals. So if I had 2, and I'm multiplying that as 97/100ths, which, since this is a power of 10, can I turn that into a decimal?
Yeah.
I can. What kind of decimal?
I know.
What kind of decimal would that look like?
That.
So 2 times
Whatever.
this. Because since I have 2 zeros, the decimal would move in 2 places. Yes, no, maybe?
Yeah.
Okay. So, how would this compare? This is my scaling factor, because my first factor is here. So my scaling factor is what I'm multiplying. So would this be greater than, less than, or equal to? If you don't know, that's fine. Just if you can figure out some kind of my product, whether you're looking at the decimal or the fraction, if you can think of a reason as to whether it would be greater than, less than, or equal to. Sophia, what do you think?
It's assumed because 97 over 100 is less than.
It's less than, because this is less than 1. This is less than 1. This is 97 hundredths. This is behind the decimal. What do you have in the ones place?
Zero.
You have a 0 in the ones place. It's less than 1. This is like 97 cents. Do you have a dollar? No. It's less than 1. So it's less than. So it's because this or this is less than 1. So if I multiplied it, I would end up with a product less than 2. It wouldn't be much less, but it's still less.
Oh yeah, it would be wow. No, I can't do that. I got confused.
It's fine. I don't multiply that in my head either. I have to write that down. 1 and 94 hundredths. It's not much. Whoop, that would be less than 2. So it's still less than 2 because we weren't comparing it to 1. We were comparing it to 2.
Okay.
And it's less than 2 because this is less than 1. My product here is less than this.
I get it.
So if I had 2, oh yeah, thanks. If I had 2 and I'm multiplying it, oops, that's not what I meant to do. And I'm multiplying it by this, which is the same as this. How would it compare to that? Sanaya, what do you think? How would that compare to 2? This, either 2 and 101 over 100, or 2 and 1 and 100. How would this product compare to 2? Get it off your head. Would it be less than, greater than, or equal to? Don't try to work it or anything. It's based on what we've been doing. Do you think it's going to be less than, greater than, or equal to? Ethan, what do you think? What? Why? Dawson, what do you think? Why?
Yes.
So, because this or this is greater than 1. $1.01 is more than $1. It's not much more than $1, but it's still more than $1. It's this much more, but it's still more. Because if I only had $1 and you had $1.01, who has more money? Caitlin. Now it's not much more, but it's still more. So if I felt compelled to check it, if you really wanted to check it to be sure, because we'd be checking this. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. Decimal moves in 2 places. 1, 2. That's 2 and 200ths. If I compare them, this is larger.
2 and 200.
It's not larger by much, but it's still larger.
Because there's 0
Because behind here, there are zeros. And if you compare them, 2 is bigger than a 0.
Yay.
2 is still larger. You may not think it's bigger by much, but it's still bigger. And 2 times but see, it is easy, but we're starting to make it harder than it needs to be. Because you're fine. But it's because we're thinking that this is not that big of a deal.
Okay.
But it still is. Bigger is bigger.
Because 100 over 100 equals 1.
Yes.
And because if we turn this into a decimal, it would just be that. Okay, so what we're going to have to do, so where it says, this is my part, okay, so when it says to rewrite each phrase, the directions tend to be a little bit confusing when you read the directions, yeah?
Yes.
And you're reading and you're going, what on earth are you talking about? Right? So, rewrite each phrase. You take it and you just kind of break it up. Rewrite each phrase as a multiplication sentence. Half as long as 8 meters. How would you write that as a multiplication sentence? Half as long as 8 meters. Half as long. How would you write that?
1/2 times 8.
1/2 times 8. Half of 8. 1/2 of 8. 1/2 times 8. And it's just taking the words and... I didn't even tell you that you could get up because we're working. So, it will be 1/2 times 8 equals something. Not asking for an answer yet. Then it says circle the scaling factor and put a box around the number of meters. So when I was doing it on the blank page where I'm always clearing it off, the scaling factor is basically what you're judging as, is it 1, is it bigger than 1, or is it less than 1? So which one of these, is it half or is it 8 that I would be comparing to 1? 1/2. The half. So the scaling factor is the one thing that I'm either comparing to 1. Ethan, hi. Are you done with the banana? Deal with it. Quit staring at it. Deal with it. So, it says circle the scaling factor. So, circle the scaling factor. Put a box around the number of meters. So if you break down what they're telling you, if you split it up, it's not quite so scary what you're supposed to do. And I think that's what happens on the ACT Aspire, on regular math tests. You read the whole thing and your head spins around and smoke comes out of your ears and your eyes roll back and you want to die. Because you read the whole thing and you go, I don't know what to do. If you go back and you read it in sections and you go, okay, I've got to do this, bang. Okay, now I got to do this, bang. Okay, now I got to do this, bang. If you break it down, it's not as bad. If you do one section at a time, do one part of the word problem, then do that part of the word problem, then do that part of the word problem. It's not nearly as scary as it was when you read the entire thing. Maybe read the whole thing, pick out the parts you need, then it's like, oh, that wasn't that bad. Write a multiplication sentence, okay. Put a circle, okay. Put a square, okay. Now, solve it. 1/2 of 8. 1/2 of 8 is
4.
Okay, so I want you to think about, Jaden, what you just said. Now hold on. If you said I did times, okay? So I want you to think about what you said. Now I'm not calling you out. I'm not making fun of you. If you did 8/16, if you did that, then you would have 8 over 8. Do I have 8 over 8? What's underneath my 8?
A 0.
No.
1.
A 1. So, because the 1 is kind of wimpy, he gets smooshed. Anytime I have a whole number, what's underneath it is a 1. I just don't see it. So if I really wanted to multiply that out, it's 1/2 times 8 over 1. When I multiply fractions, I multiply straight across. So then I end up with 1 times 8 is 8. 2 times 1 is 2. Are you seeing what I'm doing? I just multiplied straight across. Just like this. 1 times 8 is 8. 2 times 1 is 2. I can't make it any simpler.
4.
Yes, it is. No, because I'm not multiplying anymore. This is improper. So then I divide. I'm going to have to erase this when I'm done. Then I divide because this is fractions. Fractions are division. This is improper. 2 goes into 8. How many times does 2 go into 8? Tonight. Whatever you're digging in, stop. 2 goes into 8 4 times. And I'm left with 0. So I don't have to write this. If I end up with a remainder of 0, this does not become 4 and 0 over 2. That's ridiculous. You don't write that. It's just 4. This does not happen. Do not write that. It's 4. 1/2 of 8 is 4. I know, but I'm showing.
It's 6. Which is not. 8 minus 2 is 6.
Now I want you to look at this one. This one's a little bit different. 8 times as long as 1/2 meter. So, can you write a multiplication sentence for that? Try to do that one on your own. So, 8 times as long as 1/2 meter should look like 8 times 1/2.
And then
8 times as long. So my scaling factor this time is 8.
and then
Square around 1/2. And if I multiply this one out, it's 8 times 1/2. 8 over 2. You get 4 again.
This was going on.
Draw a tape diagram to model each situation in problem 1 and describe what happened to the number of meters when it was multiplied by the scaling factor. So if you have 1/2 of 8, so with this tape diagram, what is my total? 8. Ooh. What did I do to it? What did I do to it? What did I do to my total number 8? I took half of it. So each piece would be equal to 4.
Yeah, that's easy. So each side is 4, and then one of them is 4.
Right.
Oh.
Oh.
Because you only count 1/2 of it.
I don't feel like
Right. Half as long as 8 meters. So if this was a meter stick or a piece of wood that's 8 meters long and I only needed half of it, it would be 4 meters long. Oh, that makes total sense. Oh, I get it now. So this one, if I had something that was half a meter long and I had 8 times as many.
you put 8.
Ha ha ha. There would be 8 pieces. 3, 4, 5, 6, 7, 8 of them. And each of them would be 1/2. And the total would be
8 halves.
16?
8. Oh, 8 halves. It would be 1/2.
oh,
What is it?
4.
How is it 4?
It would be 1/2.
there's 8 of them. Each one is a half. The total would be 4.
I thought it was going to be the total is 8.
I know
You
that.
cover, then you cover 1/8, 1/2.
If this is a half, and 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 this is a half.
And it all equals 4.
Oh!
Hey.
I feel my brain soaking it all in. You should. Now, is this really truly going to be expected? No. They're just asking you to draw a tape diagram because sometimes you might need a tape diagram to solve a problem. Are they going to ask you to draw a tape diagram to go along with a problem? Like this? No, not really. But sometimes they want to show you the how it works, why it works, to support the math. That's all. Because once I showed you this, it was like, oh, I get it. So this is not always required. But sometimes it does help you solve word problems though. So fill in the blank with a numerator or a denominator to make the number sentence true. So this can sometimes be anything. It has to make it work though. So let's look at A. 7 times something fourths. To make it doesn't say equals 7. To make it, now that's not greater. This product would need to be less than 7. So what would our numerator have to be?
3.
It can be 3, it can be 2, it can be 1.
Over 4.
Oh my.
So if we make it 4,
And it's 28.
if we make this numerator 4, what happens to our symbol?
It's equal.
It's equal. If we make this 5, what happens to our symbol? It makes it greater. So we need to make this less than 4. So it can be 1, it can be 2, it can be 3. It has to be where this is less than 1. Less than 4/4. So you can put anything less than the denominator. 1, 2, or 3. I'm just going to put 3. Just keep it simple. Because it just has to be, are you writing this down, Jaden? Because it just has to be to where it's less than 4/4. But you do, why? Because this product here has to be less than 7.
Except for like 7 whole. She wasn't here.
Oh, you weren't here? Okay. That's right, you missed the whole thing. Okay. That's fine. Okay. You were here yesterday during bus.
But she didn't go to desk.
No.
Oh.
No.
Oh, yeah.
So, looking at 7 over something times 15. We're trying to make this product here greater. It was cold earlier. Greater than 15. So what can my denominator be under the 7 so that this product here is greater than 15?
30.
We can make it 3.
40.
We can make it, what else?
6.
6,
5.
5,
4.
4, 3, 2, 1. I want to stay away from zeros. So I just don't want to do zeros. I want to keep zeros out of it. So I can make it a 1, 2, 3, 4, 5, 6. And if I hear 0 again, when I just said keep zeros out of it, I'm going to get really cranky. So I just heard 0 again. So Because what do we need this fraction to be in order for this to be greater? We need this to be what?
It has to be like improper.
It has to be improper for this to be greater. So 1, 2, 3, 4, 5, 6 as a denominator. You pick whichever one you want it to be, you know, that, because that's whatever. So I'll put 5. You put whatever, but I just picked 5. It's a good number. It has to be less than 7, so that it will be improper. It has to be improper, so it can be 1, 2, 3, 4, 5, 6. It just can't be 7 or anything higher. If it's 7, this turns into 1, and then this symbol turns into an equal sign. It turns into an equal sign. And if I go 8 or higher, this becomes a less than sign. Because then it's less than 1. 3 times something fifths is equal to 3. What is my numerator? 5 fifths. It's in a fraction. If I put 1 fifth, did not answer the question. 5 fifths, because I need this to be equal to 1. So 3 times 5 fifths, in order for this to be equal to 3. So you're answering the question that I asked? Yeah, I'm looking at you, talking to you. Yeah, because I said what needs to be over the 5, and you said 1. Yeah. No. Okay. Yeah. All right. Look at the inequalities. When they're saying inequalities, that just means that they're not equal. They're either greater than or less than. That's all that means. Inequality just means not equal. Choose a single fraction. So you just pick a fraction to write in all 3 blanks that would make all 3 number sentences true. So they've got greater than, greater than, greater than. So you put a fraction here that would make these 3 products greater than the first factor. So we've got 3/4 times something. How can you make this product greater than 3/4? 2 times something. How can you make that product greater than 2? 7/5 times something. How can you make that product greater than 7/5? And then on B, 3/4 times something. How can you make that less than 3/4? With what you know, look up here on 3 if you can't remember what you're supposed to do. B, a fraction that would go here. Haley? Okay, what could be a fraction here, Nigel? 2 times? Alright, what could go here, Ethan? As long as it's improper, doesn't matter what you're multiplying it by. Doesn't matter that it's a whole number. Imani, what could go here? Okay? And here we've got to get less, Cheyenne.
4/5.
Because here they're getting smaller. Nastasia, sorry. I went in my brain. Go ahead.
1/2. That's all.
Need a vacation again. Okay.
Mostly.
You get it? All right, good.